let's see. Of contents. Okay, so let's talk about statistics. Okay, so what is statistics all about? You know, why do we study statistics? Why is this a class that that you are required to take and whatnot? Well, I argue the reason why we even go to school for many of these things is to help us understand the world around us. And statistics statistics allow us to make conclusions from limited data. Okay, I just remembered something that I wanted to cover in the course policies. This is a statistics class, okay? And so there are prerequisites that I assume all of you guys have met and are eligible to take this class. Specifically, I'm assuming everybody here has a good mastery of algebra, okay? And I know some of you probably do not. Some of you, you know, if you were to try to take statistics at your own college, you would have to take like 5 other math classes or something, and so you're trying to circumvent that by coming to UCLA Extension, taking the class, and then taking care of everything there. So I have to just give you a warning and say you might not pass if that's you, okay? And because you might not have the background that you need to succeed in this class. This is introductory statistics. It's not algebra and statistics. It's not all of these other things. And so it's not fair for me to kind of, quote, waste class time going over stuff that you should already know for this class, okay? And so what I don't want is at the end of the class you fail and then you complain and say I didn't teach algebra as part of the course. That's not what I'm supposed to do. Okay, I'm supposed to focus on statistics, and it takes the full 12 weeks to do that. And so, you know, if you don't have the proper math background for this class, I guess proceed at your own risk. I have success stories of people who struggled with math and you know, were able to pick up the concepts and did well in the class. But I also have many sad stories of students who tried hard, but they just didn't have the background to get them through, okay? I do my best to teach as clearly as I possibly can, but I'm also not a magician, and I can't teach you things you know, that take other people 12 weeks to cover those things on top of that. So so just please be aware of that, okay? Okay. All right, so anyway, let's go back to this. Why do we study statistics? Helps us understand the world around us. Statistics allow us to make conclusions from limited data. All right, and so what do we mean by limited data? Okay, so usually we always have a research question. Okay, we have some kind of research question, okay? Or this can be thought of as a statistical question. Okay? And what we mean by a statistical question is it's a question that is about kind of what we call a general population. Okay, so this is a research question. Is a question basically about, in the loosest sense, I'm just going to write a group of people or things, okay, people or subjects, okay. They are not questions about individuals. Okay, so let me just give you a few examples of research questions. Examples of research questions or statistical questions. And I'll give you examples of questions that are not research questions. Okay, so examples of research questions could be something like, what is the average income of American households? Okay, so here this is about a group of people. This would be American households, and this is a question about this entire group kind of as a whole. A non-research question would be, what is the income of, I don't know, the Smith family? Okay, and this would be the Smith family, you know, at 123 Main Street in whatever, Iowa, Des Moines, Iowa. All right, this is one specific family or something like that. Okay. So, you know, this is not a research question. I mean, you do have to do some research to get this answer, but this is just about one individual. Okay. You know, what is your favorite color? Does not count. Okay. Okay. But what would count is, you know, what percentage of you know, adults like the color blue, like the color blue or something like that. Okay. You know, so these are questions that that aggregate things. Okay. Not individual questions, not things that stuff like this. Okay, is this all right? And so statistics allow us to answer these type of questions, these research questions, without needing to survey every single person, right? So let me just kind of clarify this. When we say what percentage of adults, let's just limit ourselves to US adults, okay? So who qualifies as a US adult?
Men and women, 18 and up.
Okay, so it'd be all men and women in the United States, ages 18 and up. Okay, and then then we have all these like questions of like, does this count as a U.S. adult? Right? Is someone visiting our country from another country, like someone who's happens to be in the U.S. despite not having U.S. citizenship? Do they count as U.S. adult? And then like, because if we're truly going to get all U.S. adults, we have to answer who exactly is a U.S. adult, right? And these are complicated questions that, and every now and then the Supreme Court has to step in and say, oh, this counts as a person and this doesn't, and so, when we ask a question like this, we're not thinking about these things, but, if we're trying to get a complete answer, we have to think of everyone, okay? And so, let me just take this simple question. What percentage of U.S. adults like the color blue, okay? Okay, and I have no idea what the answer is here, but we can kind of get an idea what this answer is. But yeah, of U.S. adults, this kind of defines our population. This is the population, and the population for a research question is everyone that is relevant to this question. Okay, this is so, of U.S. adults, this would be all adults in the U.S. aged 18 years old and up. Okay, but we have questions. Do people, do long-time residents but not U.S. citizens count? Probably, or I don't know, maybe not. These are questions, and these are questions that people, how you answer these questions, might determine who you want to pick as a president, type of things, right? Like these are questions that it's just, we can say, oh, well, this person counts, and this, well, maybe it's always the question of like, well. So, we get, these are very complicated, and, in statistics, in this class, we're not going to get into ethics or anything like that, but just, these are things that you have to be aware of, okay? Okay, and then what does it mean to like the color blue, right? Like, so maybe it's as simple as we talk to someone and we just say, do you like the color blue? And someone has to say yes or no, and maybe someone says, I'm colorblind, so I have no opinion on the matter, or so, and you have to say, well, okay, well, the person who had no opinion, I guess they're a no. And so, like, what does it mean to like the color blue, and what exactly is blue? Are we talking royal blue only? Are we, does the sky count as blue? These are all sorts of things. But, once you have properly defined this question and how we can answer it, then we can start to get at these answers here. Okay, so, like the color blue. So maybe we just ask, survey question, do you like blue? This is a very different question than is your favorite color blue? Okay, that's a very different thing, and that's very different from do you like to wear the color blue? Would you paint your room the color blue? So, because this is probably just a poor question because I doubt very many people have extremely strong opinions about blue. Most people probably say, yeah, do you like blue? Yeah. And I imagine most people will say something like that. Of course, you'll get some people who will say like, no, I hate blue, because blue represents something, something terrible, and there's we can't explain these things behind people's lives and personal histories, but anyway, we have this, okay, and so to get this true answer, okay, what percentage of U.S. adults, so the true answer would require, a very specific definition of who counts as a U.S. adult, okay? It requires us to ask every single person who fits this this definition, okay? We must then ask every single person who counts. Okay? And then we would tally up, we would then count out of every single person how many answered affirmatively to the question, do you like blue? Okay? And then we would count how many said yes to the question. Okay? And so let's say, and so asking every single person who counts, this is a monumental task, right? This is a lot of people. This is a lot of work. Maybe there's 200, who knows? I'm just completely making up a number, okay? But perhaps there are 210,642,304 people who count as U.S. adults. I have no idea. I'm just making that up, okay? And so you would have to pull every single one of these. You'd have to track every single one down. And one of the, a lot of these people live out in the middle of nowhere, and you've got to climb a giant mountain, and they probably don't even want you on their doorstep asking these questions, which is why they moved to the top of the mountain anyway. And so this is like, just so you can ask them, do you like the color blue? Nobody has the time to do something like this, okay? But let's say we lived in some fantasy world where we could do this, and then maybe we've then wasted all of our national income just to answer this question, and the results are maybe 107,822,049 people said yes, okay, to this very important topic of discussion. And then so our answer then to what percentage of U.S. adults like the color blue would then be 107,822,049 divided by 210,642,304, and our answer, we can then punch it into the calculator. Sorry, let me just give me a second here. So 107,822,049 divided by 210,642,304. And we would say, okay, 0.5118. This is the proportion. So 51.18727,195% like the color blue or something. Okay. And we can see this is a lot of work surveying, tracking down all 210 million something adults, US adults, and then tallying up every single yes, okay? And we try to do something like that. We take the census every 10 years, and it's very expensive to do a census, and it's very hard because not everyone has a permanent address, and people are hard to track down. But we do this. We don't ask them if they like the color blue, but we try to get answers. But you can see that to get the true answer to this question would require a lot of work. Is that clear? This is kind of just a silly example of something like that. Okay, and so what statistics does is it says, well, it seems awfully silly trying to track down 210 million US adults. Can we get a good answer by just surveying, let's say, 1,000 people instead? And statistics, the mathematics behind statistics, which we're not going to study the theoretical math side, but the mathematics behind statistics says, yes, if you survey 1,000 people and you follow certain steps and guidelines in the way you pick your 1,000 people and how you do it, then you can get a very good answer. Maybe not as precise as this, but a very good answer that gets you very close to the real thing with a lot less work, okay? Okay, so statistics. The subject of statistics says we can get, a very good idea of the answer with a lot less work. Okay, we don't have to survey every single adult. Okay, we can just ask, we can survey, 1,000 adults. Okay, and as long as we follow certain guidelines, in the way we choose our people, our results can still be very accurate. Okay, so maybe, so here we take what we call a sample. So sample is, a selection of people that represents, that should represent the population. Okay, so think of this big circle as the population. This circle or oval represents the 210 million US adults. And from that, we're just taking a tiny little circle, tiny little piece. Excuse me. I'm getting over a cough here, so getting over a cold. So if I cough, I apologize. And this is our sample. And so this is, the population is too big to observe directly. And the sample is, a small selection that we can work with. Okay, and so maybe our sample says, 529 people say yes out of 1,000 people total. And so our answer would be 52.9% like blue. Okay, so according to our sample, (52.9% like blue), and that's just 529 divided by 1,000. Okay, so far so good. Okay, and then we we throw in something called a margin of error. We say with a 3% margin of error, and we'll talk about how exactly the margin of error is calculated and all of that, but this is probably a term you guys have heard of somewhere, especially common now that it's 2016 and it's an election year. You always hear about these polls. You see, this and this candidate is polling at this percentage, blah 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 blah. And they come with these margin of errors. And sometimes the margin of errors are like 30% or something, It'll be like someone says polling, at 40% with a margin of error of like 30%, which means that person can be anywhere from 10 to 70% or something like that. And early on, it's, nobody can predict the future, and so, poll results early on are very hard to, it's hard to depend on these types of things, but with statistics, at least they give us an idea of perhaps what our population might look like. Okay, so that's kind of the big picture behind statistics. We have these research questions about a population. The population is way too big for us to observe directly. We don't have the resources to survey all 210 U.S. adults, or if we're surveying every single person in the U.S., that's over 300 million people. We don't have the resources to do that, but we don't have to. Statistics says, hey, we can just get away with surveying a few hundred or a few thousand people, and based on these results, we can then kind of make conclusions about the population, and so that's where we're headed. There's a lot of kind of background work that we have to establish before we can start doing these kinds of things. Okay, but so we are headed. So in the class, we are headed towards the picture, or towards the idea of statistical inference. Okay, and this is the idea of making conclusions about the population based on limited data from a sample. Okay, so this is where we are headed. And so this requires a few different pieces, okay? So first we have to talk about what we call descriptive statistics. Okay. Okay, and so descriptive statistics is all about summarizing a bunch of data into one or two numbers, okay? So descriptive statistics, we summarize lots of data, lots of information into just a few numbers. Okay, into just a few numbers that are important. Okay, and so, you know, if you ever watch sports, you're very familiar with this idea of summary statistics, okay? So if you guys follow basketball, the Golden State Warriors have had a tremendous season so far, okay? And so, you know, they can tell you, I can go through, we could go through every single game log and say, you know, this is how so-and-so performed, and we can go through every single bit of information, but we have a summary statistic, and we can just say, you know, their win percentage this season is 93% or something like that, okay? They've lost 2 games this entire season, whereas maybe the average team has maybe a win percentage of around 50%, okay? And so just knowing that that they are up, you know, having won so many games, just tells you something, okay? Or, you know, it's you know, the NFL playoffs and things like that, and every quarterback gets, you know, a passer rating, okay? And at the end of each game, okay? And you can watch the whole game and you can say so and so had a good rating, good performance, or things like that. But you can also just say, oh, so and so has a passer rating of this number versus this number, and it's just a single number that kind of is supposed to tell you how well or how poorly a person performed, okay? We can talk about from country to country, and we can say the U.S. is a rich, wealthy nation, and, you know, these European countries are wealthy nations, and this other country, you know, Bangladesh is a poor nation, or, you know, we talk about third world countries, and we can talk about all of these details and, you know, their economies and things like that, but we can also just summarize it with, you know, GDP per capita, which is kind of how much output a country produces per person, and we can say, you know, for the U.S., I'm making up numbers, I have no idea, maybe it's like 40,000 per person, whereas, you know, this other country, it's maybe like $400 per person or something like that. And so, you know, these single numbers just give you an idea, a picture of how you can compare something very complicated, like an entire country's economy, into a single number. And it doesn't tell you very much. It doesn't tell you, you know, is their economy based on technology or agriculture or whatever. It doesn't tell you, you know, whether the government has corruption, or it doesn't tell you any of these other things, but just a single number can give you an idea of something very complicated. Another example that you guys are probably all very familiar with is your GPA, okay? Your GPA is a single number that's supposed to summarize your entire academic career in college or high school or whatever it might be, okay? And, you know, so let's just think of your high school GPA. a lot happens in those 4 years, right? Maybe you entered high school prepubescent, and you underwent a lot of change, and all of this stuff happens, and but we're supposed to summarize it with just a single number, and maybe it doesn't capture everything, but you know that a student who graduated with a 4.0 GPA versus the student who graduated with maybe a 1.7 GPA, they probably had very different study habits, okay? We don't know very much else about their life, but just those single numbers can tell you quite a bit. And that's what descriptive statistics is all about. We're just taking lots of information and summarizing it into just one or a few numbers that is supposed to give us an idea of how they go, okay? So that's one part. Another part is probability, okay? So probability, this is kind of the mathematics behind how likely things are. Okay? So are things likely to happen? Are they unlikely to happen? Okay? And so we will spend, this is kind of like weeks 1 through 4, okay? Probability will be weeks 5 and 6. Okay, and then these come together and we start to ask how likely or unlikely is a certain statistical quantity. Okay. Okay, and this is where statistical inference comes in. And so this will be basically weeks 7 through 10. Okay? And then week 11 will be a review, and week 12 is the final exam. Okay? Okay, so we'll start by entering this land of getting into descriptive statistics. Can I flip to the next slide? Okay. So when we talk about data, we have two types of data. Or also maybe we call these types of variables. Okay. We have numeric variables, also called quantitative variables. Okay, and these tell us how much or how many. Okay, and we also have categorical variables, These are also called qualitative variables. Okay, and they tell us what type or what kind. Okay, so for example, we can let's say we wanted to collect data on vehicles. Okay, and so maybe we ask, we're not going to do this, but we can just ask, what is the make of your car, the model, year, its mileage, how many passengers fit, or maybe not passengers, but how many people fit, I guess. I don't know, the color, etc., etc., etc. Okay? All right, and so maybe somebody drives a Ford Fusion 2010, and it's got 68,047 miles. It fits 5 people, and it is silver. Okay, something like that. Okay. All right, so I think it's very clear. All right, okay, so this is person 1, and then person 2 maybe drives the BMW, what is it, 5 Series from 2006. It has 120,845 miles, and it fits 5 people and black or whatever. Okay, who knows? Okay. I wonder which car would have a higher resale value right at this point in time. I have no idea. Okay, so anyway, so I think it's easy to see. This would be. I'm going to just write categorical. Categorical is year numeric or categorical? Yeah, it's arguable. Okay, I would probably say numeric. Mileage would be numeric. How many people fit? Numeric. Color. Categorical. Okay, yes, question?
How come the people that it fits would be categorical if there's like coupes that fit only 2?
Mm-hmm.
Sedan fits 5.
Well, not all sedans fit 5, and not all coupes fit 2, and there are, I don't know. So the question is, does it tell you what type or what kind? Now, I could have another question that says body style, right? And this would be sedan, and then this would be a sedan, okay? And maybe these contain kind of overlapping information, but knowing just how many, if I tell you a vehicle fits 4 people, does that tell you what body style it is? No, right? Because it could be a Jeep, it could be a sedan, it could be, there are coupes that will fit 4 people, right? It's uncomfortably, but it will fit 4 people. So telling how many people fit just tells you how many people fit. It doesn't tell you the body style. At the same time, if I tell you body style, if I say this car is a coupe, how many people does it fit? You also don't know. It could be 2, it could be 4, it could be 3. where they had like those bench seats in the groups back in the day. Um, so, so yeah, they are different bits of information. So you're right. A lot of times there is a high bit of redundancy in some of this information, but they are not necessarily, one doesn't necessarily go with the other. Okay. Okay. So, let's say we went around the classroom, and we're not going to do this, but if I asked you for your zip code, is that numeric or categorical information? Okay. A zip code would be categorical, okay? It tells you, it's hard to think of it as a what type or what kind, but it certainly doesn't tell us how much or how many, okay? It doesn't make sense to say, I have 20 more zip code than you. That's not a comparison you can make, okay? However, things like height and weight, those are numeric. Those tell you how much, and you can say, I weigh 20 pounds more than you. You can say, I am 3 inches shorter than you. You can make these types of comparisons. Whereas with categorical things, it doesn't quite make sense to do that. So numeric variables, these often come with units, often carry units, and it makes sense to make comparisons between observations. Make comparisons of quantity. Okay. Whereas categorical, you can make comparisons, but not in a numeric sense. Okay. You can say so and so has, maybe like if you're talking about hair color, you can say so and so has darker hair than someone else, but you can't really quantify it unless you've turned it into a numeric variable, which, I don't know, you get like some numeric value for saturation or something like that. Now that we have digital photography, everything at some sense can be quantified, but in most day-to-day aspects we don't do that. Okay, so that's so it's very important that we can tell the difference between numeric and categorical data. I'll come back to that in a moment. As you do your homework, you're gonna read through the textbook. Let me just say this about how you should do your homework. One thing you should not do is don't read the textbook like it's a novel. Okay? Don't read through it and go and then go to the problems. What I would say is actually, and everybody has different learning styles, but I would say, throughout this week, at least 3 days during the week, don't save everything till next Tuesday to start studying. At least 3 days during the week, open up your notes, review kind of the notes that you've taken in class, or the notes that I'll post online, and then go directly to the homework problems that I've assigned. See how much you can do without any guidance. Okay, and if you don't know how to do it, then flip back into the book that is related to the problems that I've assigned. Read that section and then try to answer those questions. Okay. and kind of do this back and forth. Look at the problem, do as much as you can. If you get stuck, go back into the text and check. Go through your notes and check. If you kind of just read everything all at once, it's just going to get jumbled in your head, and you're going to mix up concepts from here and there. And I think having kind of the homework problems to kind of say, here's the topic that I need to know, and here's another topic. I think that kind of sets up little anchor points in your knowledge. So anyway, do that. There's a lot in the textbook, and so some of it I kind of gloss over in lecture. But if it's covered in the homework, then it's stuff you're expected to know. Okay, so I have a few problems in the homework that you're going to just kind of have to flip through in the reading. It shouldn't be so complicated that it's impossible to grasp. And in those cases, I also have, I think, a lot of them I've recorded video solutions for you guys. But it should be easy enough to grasp. So anyway, do your homework and do the relevant reading for each of the problems. So we can think of, when we're thinking of data, okay, try to think of raw data as a table, okay, where each row represents a subject, or person or thing being studied or observed. Okay. And each column is a variable. Okay, and then when you hear a research question, think of how your raw data table should look like. Okay, so when you hear a research question, so let's say our question was, what percent of adults like the color blue? Okay. And so let's say the data we collected is, we collected data on 1,000 randomly selected adults. Okay. So our raw data table, how many rows will this raw data table have?
You'd have age.
So, well, okay, how many rows? So each row represents what? Yeah, so how many rows would I have in my table? I would have 1,000 rows, right? So whatever my table looks like, I'm going to have 1,000 rows. Okay? So one row for each person. how many columns would I need to answer this question? Okay, what are these columns? Yeah, to answer this question, I only need one column, and that is, do you like blue? Okay, and that's either going to be yes, no, yes, yes, no, so on and so forth. Okay. Do I need any other columns here? No. What, you have a question or a hand?
Wouldn't you have to ask first if the people that say maybe, is that considered a yes or no, and then if you don't do that, you make a maybe column?
Well, you don't need a maybe column. I mean, if we're gonna allow maybes, then you know, we could throw in a maybe in here or something. Okay. But well, this is all defined. So when we do our survey, we have to have these answer choices very clearly defined. Okay. So it's either yes or no or something else. However you have it. But you don't need a separate column for yes. You don't need one column for yes and one column for no and one column for maybe or something like that. There's no reason to have that. You just, do you like blue, and you record the answer there, yes or no. Okay. Now, if we wanted to ask questions like, what percentage of men like blue, then we would need to have a column here for what? Yeah, what sex are you? Are you a man? Yes or no? Okay. Or, you know, however we want to ask that question. Okay. And so you want to think of these questions. So and how your table should be set up. If you want to start asking all of these complicated questions, like so news organizations like to say, you know, what percentage of, you know, white voters in West Virginia like this candidate, okay, versus what percentage of young minority voters in California like this candidate, or things like that, okay? Then you need to have a column for, you know, do you like this candidate, yes or no, or, you know, which candidate do you support, and then, you know, are you young, you know, are you young or old, or what age are you, and what is your you know, ethnicity, and are you male or female, you know, all of these other things you gotta keep track of, and then you use your software to kind of organize and pull out these questions. But you know, you don't, if the question is just, do you like blue or not, you don't need all of these other questions, and only if it's you're trying to make a relationship between this and other things here. Okay, it's 8:30 right now, so let's take a 10-minute break. We'll come back at 8:40, and then at 8:40 we'll continue and we'll finish up the class.